Hello guys, so this is the second part of my weapon system feature breakdown, and in this video I'm gonna talk about the equipment system and also drop a few words about the surface and foliage interaction. You may think of this video as a 101 tutorial, so for those of you who have the sample project that I recently shared, you can better understand the idea and the pipeline I used to make this feature. So you can actually expand this system further. As I recently told you, this feature is heavily inspired by the game called Destiny. So some of you, maybe it will suit your project, but it can easily be changed because this system is kinda universal. Also, I'm gonna update the sample project on my Patreon with the foliage and surface interaction. This tutorial is kind of long, so I'm gonna emphasize my attention on only valuable parts and most hard one, and obviously I'm gonna omit some easy stuff that you can make on your own, like visuals and so. So before we start, we need to make 5 widgets, so then we can fill them up with the data. We need them now because we have some references in our equipment component. So we need to have the game menu, the parent widget, which will hold our equipment, inventory, and game settings. So we also need to have equipment widget, inventory widget. Equipment widget is also a container which will hold equipment slot and equipment reserve. So if you remember from the Destiny, once you hover your mouse or the points over current active elements, it might be an equipment or weapon or consumable, it will show up a table which contains of 9 more elements that we can keep in our character under one specific category. Let's say it's the special weapon. So that's why we need to have equipment slot and equipment reserve. Just before we start with the equipment component, you need to be sure that your main parent widget, the game menu, has references to the equipment and inventory. In my layout, I have them both under the widget switcher, so make sure that you have yours. So now, in the equipment components, the main graph looks kinda obvious. So the begin play, we create our game menu widget, and from it we expand the references for our child widgets, the equipment and inventory, and store them here as the global variables. So then we can use them to call up functions that we're gonna make in those widgets further in this video. On the end play, we simply remove the game menu from the parent and store it as the null reference, so then garbage collector can kill it. So the I key here is for showing up my menu, and if the game menu is valid, I can move on. It checks whether it's already been in the viewport, so I can rather open it or close it. This part is from the previous tutorial, but I'm gonna explain it one more time. So here I have the enhance input action, and I store the amount of seconds that I've been holding up my key. So if it's more than specific threshold, it's gonna set the boolean called switch to have it triggered to true, and that means that if I'm holding up my key for quite a while, I'm gonna switch my weapon to the heavy one. But if the threshold is like the condition isn't met, I'm gonna immediately switch between my primary and special weapons. This part isn't, you can skip it. So guys, now let's make some functions, and first of all we need to provide the input and output data for those functions. Right after this, we're gonna make an implementation. I'm gonna explain what each function does. So starting first with the try, pick, and equip. The input is incoming item, and it stands for the item object class. It's the custom blueprint, which is derived from the object, so it means it doesn't have any physical representation. It's the raw data and functions. And the output is Boolean. So this function runs more complex checks, and the result is that item that we're trying to pick up in the world. If we succeed, so it's gonna transfer the data to the equipped component and be destroyed. Or if we fail, we're gonna leave this item laying on the ground. So the next one is can equip or store. It has the same input, but the output is two enumerations. So they are slot state and the item type. For the slot state, we have three different outputs: empty, leftover, occupied. For the item type, and this can be expanded once your system gonna grow. For now, I'm using only 4 of them. It's the consumable, weapon primary, weapon special, and weapon heavy. So this function tells the status of each slot. Rather, we can place our picked item in it, or we should skip and try to find more appropriate place. Moving next, can store for stackables. The function has the similar logic, except one difference. And I'm talking about the can equip or store, because as you can see, it has the same input and output. So let's say you have not unique item, but, and I'm referencing most of the time to the consumables, like food, beverage. Let's say you have the 5 apples and the maximum stack of it is like 6. Until you reach this condition, this function will return, in this particular case, the leftover status. But once we meet the condition, it's gonna return occupied, and then we need to find more appropriate place to store our apples. So that's the idea behind this function. Next one, can switch weapon common, can switch weapon heavy. Both functions return the Boolean type and both are pure. So they are only getters, and I don't need to calculate make any calculations inside those functions. The status they return prevents me from switching the weapons if they are invalid. So I'm checking whether I have in each primary, special, or heavy slots any active weapon. If this slot lacks the weapon, then I cannot switch between my current slot and the one that I'm checking with. So guys, the next one is get weapon switch index. It's a pure function with the output of integer. It's kinda hack, but for now it works pretty much fine. Maybe I'll rewrite it in near future. So based on my current weapon type enumeration, I'm assigning different indexes for the weapons. And the design of my weapon switch logic is the following. I need just with one key, but with a different interaction, whether it's a simple press or my keys being hold, I need to switch in the following order, like from primary to special, vice versa, and from primary to heavy, vice versa. This function really comes in handy in this particular situation. So next, item equip. The incoming item is the item object class. It's our input. Basically, this function just spawns the weapon or other piece of equipment and registers it to a slot. Item store. This can be used in 2 different ways. So if we cannot equip our item, we need to store it to the reserve, or if this one is a consumable or the quest item, it's gonna save it to our inventory. So for the input, incoming item is the same. We also need to define the slot where this item should go, and the result of this function, whether we succeeded or not. Item replace, the input, the original item and the item to replace. So it's if you want to swap between our weapons, like the primary and special, primary and heavy, and so on. The same will go for the other piece of equipment, like the armor, once I'm done with this. The next one is item use. Basically, it's for the consumables, like the food or beverage, so I can use it and get some bonus. The same input, like in all this feature is based on using the item object class. And the item dismantle, item to remove. So basically, this function is called if I need to have some free space and I like could not place any new item to my equipment. So item update story. You can skip this part as I'm not gonna cover it. Basically, it's for like it's implementation. Like if I have the quest item stored in my equipment, so I can track the progress with my quest system that I made a long time ago, and I also have a tutorial on it. Well, next, weapon spawn. The input is the same, item object, default blueprint class, and this function right now is only for spawning the weapon, and once I have the equipment, other equipment in my game, as I said, like the armor and so, I'm gonna have the different, or maybe like rewrite these functions to be universal for each item, but still this one just spawn an item and attach it to a socket on my skeletal mesh. Weapon destroy, basically if I want to dismantle some item in my equipment to have some free space, I'm gonna call this function, and we need to provide the like weapon to remove. Weapon attach, so here we have incoming weapon, but the class is the actual physical asset, as we're gonna like create from the item data, from the item object class, we need to spawn an actor with the actual transform, with the model, animations, and some other stuff. And this function is gonna attach our newly created weapon that we have in the weapon spawn. It's gonna attach it to the skeletal mesh. And the weapon switch, the function that you already saw in the previous tutorial and in this one, basically the function will like perform a swap between my current weapon and the weapon that I want to switch to. Now guys, let's quickly create some variables that we need to have so we can operate here in the equipment component. So we need to have the last active weapon primary, and the type of this variable is the interactable base class. It's like the physical actor that we're gonna use to represent our weapon in the world. So it's also from my previous tutorials. It's the universal class that I use for all kind of items, like the weapon, the equipment, the consumable. The same one goes for the last active weapon special, last active weapon heavy. We also need to have the current weapon, the same type of variable, interactable base. The array of the item object class, the reserve weapon primary, reserve weapon special, reserve weapon heavy. So here we just need to store like all the not physical data, but like raw inputs, like data, the function that not the functions, but the data which we'll use for creating or spawning the weapon, the other piece of equipment, once we need to switch between our current and the new equipment. So also boolean switch to heavy triggered for performing the swap logic, and switch to heavy triggered time. So it's for the enhanced input system, so we can track how long we have been holding our key. We also need to have the item list, and it's the array of the item object class. It's not for the equipment, but for the inventory, like for consumables, quest items, and so. And those widgets we already have, because we made them right up here at the beginning of this tutorial. And we also need to implement two event dispatches, but it's from the previous tutorial, like on weapon equip and on weapon unequip. So we can have subscribers that's gonna perform some action once those dispatches are gonna be used. So the function implementation. The first function is try pick and equip. We need to check whether incoming item can be equipped or stored. So we're gonna call function call can equip or store. I know that we don't have the implementation of each function yet, but as we have the outputs of each function, we can build up the flow in each function. I store the slot state into slot as a temporal variable, so I can use them further in this graph, so my graph looks cleaner. And based on the slot state, I'd rather equip item and return true, or if I have leftover, it means that I'm using consumable. I need to check whether I can store it to the inventory. And based on the result, I rather store it or not. If I cannot do this, then I'm gonna just leave the item laying on the ground. And if the slot is occupied, it means I cannot place it to the reserve equipment. And here I'm talking about only equipment, not the consumables or the quest items. I'm gonna return it's false and also leave item laying on the ground. So next function can equip or store. So here I have a sequence just for the graph to look cleaner and tidy. As if I put everything in a line, it would be kind of hard to follow up and just to navigate. So from the incoming item, I extract the item data, and based on the item type enumeration, in this particular case, I'm checking whether it's a consumable. I'm gonna check conditions so I can store item in my inventory. The item list here, and the length is 50. So let me show you. I'm talking about this layout. If it's less than 50, then I can check condition for the can I store for stackables. And if it's not, I'm just gonna say that all my slots in my inventory are occupied, and I'm gonna leave this item laying on the ground. And this is for the items like consumables, quest items, and maybe some money, some resources, I don't know, not the equipment stuff. And here comes the equipment part. So as I told you earlier, I'm gonna use the weapon primary, special, and heavy. I'm gonna check whether I have in each category last active weapon valid. So those variables that we created. If I have one, I'm gonna then place the item that I wanna pick up to the reserve based on the category, and also I'm checking the reserve weapon primary, special, and heavy array lengths, and if it's less than 9, also talking about these parts. If it's less than 9, then I have leftover, and I can try to put item to the reserve array. And if it's not, I'm gonna leave it as occupied, and also this item gonna be laying on the ground. So, and if the item is not valid, it means that I don't have any item yet, don't have any weapon. So I can pick it and place it to the current slot, the first one. So check the graph one more time. Moving next to the can store for stackables. So I'm gonna check whether item list isn't empty, because if it's so, I have all my slots free, so I can just place it to whenever slot it's gonna be. And by default it's the top left, and so on. Then if it's not, I'm gonna iterate over the item list array, and I'm gonna check the incoming item and the item in slot per each slot for the ID that I have stored in the item data. And if those ID are equal, it means that we are checking on the same item type. I'm going to check the current quantity that I have in the inventory and the max per stack that I can store. And if it's not the same number, I'm gonna return the leftover, and then it means that I can accumulate and put one more consumable in this stack. And if it's not, then I'm gonna return the occupied, and it means that I cannot have any item of this type anymore in my inventory. And on the complete, I'm just gonna return leftover and consumable. It means that if I ran all over the items and I haven't found any of them, then it means that it's a new item. So the conditions that we checked here were not met, so I can just put it to the next free slot. So the next functions are can switch weapon common, can switch weapon heavy, and get weapon switch index. So as I told you earlier, also in the previous tutorial, these functions allow me to swap between my primary and special, or primary special to the heavy slots. So in the first function, I'm checking whether both of my primary and special slots are active. By this I mean I have some weapon. Like if I open up my equipment, I don't have anything. If I pick up, let's say, auto rifle, it's equipped, but I cannot switch to anything because I don't have the primary slot yet. But once I've done this, now I have the pistol, the auto rifle, and I can shoot with my pistol, then I can switch to my auto rifle, then back to the pistol. And this comes with the simple key press. Like this. But I don't have any heavy slot, so I need to go and pick, let's say, a shotgun. I've changed the data table of my items just for this demo. So now we can see I have a shotgun. So I have a pistol, I have an auto rifle, pistol, auto rifle, but as you remember, I need to hold the key so I can switch to the heavy slot. And now if I press a key and hold it, I have a shotgun like this. But if I press key just one more time, I'm gonna go back to my main logic. So I have a pistol, auto rifle, pistol, auto rifle. If I press and hold, it's back a shotgun. So those functions are for this. And get weapon switch index, I'm checking my current weapon that I'm holding in my key at this particular time. So based on the item type, I made sort of a hack that I also told you earlier to assign a specific index so I can perform my switch logic. So if it's a primary, it's going to be 1, if it's special, it's going to be 0, and for heavy, it's also going to be 0, just by now. Well, guys, I guess it's time for us to move to our widgets and create some placeholder functions, so then we can continue with our equipment component. As you see, for instance, in the function called item equip, I have a call from the equipment widget reference to a function that actually doesn't exist yet. Maybe on your side, right? So to continue working with the logic here, let's implement those functions as we did for our equipment component several minutes ago. And not to make the things twice, let's make those functions for all of our widgets. And we should start with the game menu. So here at the graph, I have a function called update active widget with the input of integer. Name is new active index. Just make one. Now, equipment. To the graph, here we have preview reserved weapon menu, no input and output. The same goes for the init equipment UI. I also have three different functions called on menu, primary, special, and heavy. So if we go back to the designer and you take a look at each of those buttons, they actually are not buttons, it's the menu anchor, and this kind of widget works the following way. If you hover your mouse over this widget, it will show up a pop-up message or like a table which contains of, in my case, 9 more elements. So to have these sort of functions appear in your graph, you need to, in your details panel, scroll down to the bottom, and here under the events category, select on the bind on the get menu user content and press create binding for all of those buttons that you have here, those elements, just in case if you want to have the same layout, the same behavior as I have. So yeah, this. Outputs will be generated by default. So next one is equipment reserve. To the graph, and only one function called init equipment reserve UI, and that's it. Next one is equipment slot. So here to the graph, we have the function called init equipment slot UI with the input of the incoming item. It's the item object class reference. And get last active weapon widget. Here we have the output, and the output is the reference to this current widget. So it's the equipment slot version 2 in my case. I also have some functions overridden in the mouse event. Actually, it's one function on mouse button down. Those two, mouse use, equipment, and inventory, are custom functions that I made. I just select them to be under the category of a mouse. So the first one, how to make this, hover your mouse over the plus button here and you will see the override drop-down menu. Select it and go to the on mouse button down. You don't see mine because I already have it, so that's why it won't show up right now. For the mouse use, equipment, and inventory, you need to provide the input of the mouse event, and the type is pointer event. And the last one is inventory. To the graph, and we have init inventory UI without input and output, and update inventory UI. Also, just a simple function with no data needed. Item equip. Back to our equipment component. Here, based on the incoming item type enumeration, as I don't have ammo yet, but for all of my weapons, for primary, special, and heavy, I'm gonna call a function called weapon spawn. And based on the incoming item, it's gonna spawn a particular item with particular settings. Right after this, I need to call a function from my equipment widget, init equipment UI. So once I open up my equipment or inventory, it's gonna show proper icons, animations, and so on. The next one is item store. This one looks familiar as can store for stackables, something like this. So here, first of all, I check on which slot my item is gonna be applied. If it's a consumable, then I need to check whether I have free space in my inventory. And if it's so, I need to iterate between all of my items, check whether the incoming item had the same ID as the item I am like checking this item with. And if it's so, then I need to track the current quantity of item in inventory with how much I can, or how many of these items I can actually store. So if it's not the same amount right now, if I haven't reached the max, I need to call a function which is implemented inside the item object class, add item to stack. And it looks like this. Basically, each item has its current quantity, which begins with 1, because 0 it means nothing, right? Then once this function is called, I need to increment it and clamp by the max per stack item, something like this. If all those conditions fail, it means that I cannot add any item in stack. That it means that I need to execute another part of logic. Once everything is done, on a complete, I'm gonna add the incoming item to an array item list. So my inventory will know that in a particular slot there is an item with the particular number of items. But if we talk about the equipment, then we need to add items to the array for our reserve for our equipment. So as you remember, we created several different arrays: item list for inventory, and reserve weapon primary, special heavy for our equipment, right? So based on the to-slot enumeration, make a switch, and for primary we store item to the primary, special to special, heavy to heavy, and return the true. So now it's time for us to fill up some functions inside our widgets. So we need to have an equipment widget opened, and if you remember, we made binding on 3 different menu anchors, in case you have the same setup as I have. So I'm talking about those elements, this, and this. So those functions are on primary, on special, on heavy, get user menu content. So each of them creates a separate widget with a particular setting. This setting is described inside the equipment reserve widget. So you need to make here a variable called item type and define it as the item enumeration. Make sure that this instance is editable and you selected expose on spawn, because otherwise you cannot define this variable once the widget is created. And this one is like a must. So go back to the equipment widget, and for the first one on menu primary, we create the equipment reserve widget with the settings of primary and store it to the global variable called reserve widget primary. Same goes for the special, and same goes for the heavy. So we need to have like the reserve widget primary, special, and heavy global variables. Once we've done this, now we can go back to our equipment component and talk about the item replace function. So in this function we perform calculations before we can do the swap operation. So based on the original item, I extract the item type enumeration and use select node. This operation helps me to understand which reserve weapon array I'm gonna use, whether it's primary, special, or heavy, and I store it to the temporal array. Next, I need to find what index inside the reserve equipment my original item was assigned to. So I store it also to the temporal variable. If this index is valid, I simply need to use set array element function and provides the item to replace as the new item on the already assigned index. I also create the temporal variable for boolean, so then I can here check whether it was success, and I can continue. If it's not, I simply won't do anything. So also based on the original item type enumeration, I use simple switch and I update the particular reserve weapon array. Right after this, I need to call a function init equipment UI to update the icons and animations inside my equipment widget. And I also need to call init equipment reserve UI. So once I hover my mouse over the element, it's gonna show me updated reserve equipment. So here is a tricky part, because based on the original item type enumeration, from each widget that I have, like I have one widget reference here, but it can have 3 different references here. So based on the item type, we can actually go and select what type of widget we're gonna update, rather it's weapon primary, special or heavy. And that's how it looks. So we have like this, we open up our equipment and we can swap our elements like this. So next one is item use, and almost all of the time in my game, in my feature, I'm using this function to perform on the consumables. First of all, we need to spawn an actor, and from the incoming item I get the class and I spawn this item using the temporal transform. The location is minus 10,000 units, so I don't need to see this actor, because I only need to execute a function on it and then I'm gonna destroy it. So if I have a reference to it and I'm storing it like this, I call a function called useItem, which by default is it's like in the base class, the base interactable class. And I also have a separate tutorial on this topic, probably inside the interaction and the point and click interaction. There are 2 tutorials on this. Basically, using this function inside each of actor has its own logic. So they all have different effects. Once I've done this, then I need to manage the temporal interactable lifetime. And the best way is to use the set lifespan, because this one won't return any error. Then I use item dismantle on this item dismantle. We need to use this function in case we have some we don't have any space in our inventory or inside our reserve in the equipment. So we use item to remove to understand what type of item it should be referenced to based on the item type enumeration. I use select node to understand whether it's a consumable or reserve weapon primary, special or heavy. So I store it to the temporal variable, and then I need to know which index I'm gonna be removing from. So if this index is valid, then I need to understand if it's a consumable or if it's equipment. If it's a consumable, probably it should be I'm talking about some stacks, and I need to call a function remove item from a stack. This function is implemented inside the item object class, and it looks similar to the add item to stack, like this. But here is an opposite operation. We decrease the counter and clamp by 0, so we won't get any negative value. This. Next one, we need to check if the current quantity of an item is actually 0, because if it's so, we need to remove this item from the inventory and shift all UI. So if it's true, we need to remove index from the array and update our item list with the newly updated array. Right after this, we call update inventory UI and return success false. Because once it's done, we don't need to perform any of these operations with our equipment. If it isn't true, it means that we need to remove item from the equipment. So we use remove index and return true. If return true, we can continue, and we're gonna execute nearly the same logic as we had in the item use. In the item replace, like this. So based on the item type enumeration from our item to remove, we update reserve weapon primary, special, or heavy with the new temporal array that we actually modified here. Right after this, we call init equipment UI and init equipment reserve UI, also based on the same logic as we had here. And that's it. So, weapon spawn. The first thing is to define the transform into which our weapon or piece of equipment gonna be placed. For this, from my current player, I have already predefined socket with the name of weapon right. I get transform of this socket and store it as the temporal variable. Next, I need to spawn an actor, and I spawn it at the correct position with the correct rotation. The class gonna be defined inside the item data that I get from the item object. And next one, based on the item type, I would rather spawn primary, special, or heavy weapon. I also need to update the newly spawned as the last active weapon, and it's also the current weapon. Then I'm gonna call a function called weapon attach and provide the incoming weapon with my current weapon. Then I need to call both dispatches, because my flow is that once I have a physical representation of an item, of an equipment in the world, once I dismantle it or destroy, I need to unequip it. Then, because I already have the new spawned actor, right? As this one is the new current version, I'm gonna call on weapon equipped. And that's it. Now we're gonna talk about the weapon destroy. So based on the item that we're gonna destroy on this item type enumeration, with the select node, I'm gonna destroy whether it's primary, special, or heavy. As I told you earlier, set lifespan is the best way to manage the lifetime of your entity. And then I need to set the null pointer depending on the context for whether it's primary, special, or heavy weapon. So if those are invalid, then the logic that I executed earlier, once I pick up an item and store it, it's gonna be correct. And I also need to call to this on weapon unequipped dispatcher. Next one, weapon attach. So, as you know, my items on the scene, they have physics enabled. So if you take a look, they dropped, and just the best behavior, not them to be floating on the ground. So it's kind of semi stylized game. So once we need to attach an item, first of all, we need to get the primitive component from our item and set simulate physics to false, so it won't be messing around with the physics asset of our character. Then there is sort of interesting thing that we need to reattach components of our incoming weapon to a new root. I found this solution on the internet. As you can see from the tooltip, it restore mesh hierarchy after physics manipulation. Because without making this operation, once you pick up your weapon, it will, I guess it will be at the same position, like it preserves its position, location, rotation, and so on. Let me just quickly check. I pick it up. Yep. That's what happens. And once this one is done, we need to attach our weapon to our new parent, and the parent is the socket of our layer skeletal mesh. And the last one here and inside the whole equipment component is the weapon switch. So once the weapon switch is called, we need to call on weapon and equipped dispatcher, set the new current weapon based on the index that we get from calling up this function, and then we need to call on weapon equipped. So guys, finally we can talk about the UI. Hopefully it won't take long. So quick overview of the game menu widget. So we have the background, we have the widget switcher between my equipment and inventory. I also have two buttons, like the equipment and inventory. So pressing on each of them, I'd rather go with this representation of the layout or with the inventory, like this. Now to the graph. On the construct, we need to disable the input for our player, so I cannot move while my UI is on the screen. On the destruct, I'm gonna re-enable my player to walk to perform some actions. I also have some controls here for the camera, but you don't need to do this. Also on the construct, I need to set the default index of my widget switcher to be 0, as my equipment is the default state of the UI layout. Once I press those keys, as I said earlier, we rather go from the index 0 to the 0, from 0 to 1, and also I need to update the inventory UI once the inventory is on the screen. I have this reference here because I've done adding those UI widgets right up here in the hierarchy. As for the functions, update active widget. We have two global variables, the active widget previous, the active widget current, so I can perform the switch between those widgets in the widget switcher, right? So I get active, I set it as the previous, I set new index, I set it as the current, and vice versa. And based on the current active index, I'm gonna update the render opacity of my of the text of the widgets that I have inside my buttons. So right now it's fully opaque, this one is transparent, and vice versa, like this. So next one is equipment. So basically it's a simple vertical box which holds the menu anchors. So menu primary, special, and heavy. I also have two spaces, so just for better visual representation. As you know, those menu anchors they have overridden functions, the context one, so I showed it earlier. Now go to the graph, and here on the construct we need to call function init equipment UI, and on netgeek we're gonna call a function preview reserved weapon menu. So we're gonna start with this one first, and here, based on the menu primary, special, or heavy, we check whether each of them are hovered, and if it's so, we need to close others and open the one that we are hovering over. So it's kind of easy, it's not rocket science, might be done better, but for now it works fine and I haven't seen any struggle in the performance. So just like this. And other one is init equipment UI. So in a sequence we're gonna cast from our, like we have a reference from the equipment component that we, yep, on I forgot to tell you about the on initialized. event, we need to get player controller. It's the place where I store my equipment component, and I store it as a reference here so I can use it further in the in this blueprint. So once this one is done, from equipment component we get the last active weapon: primary, special, and heavy. We cast to the weapon base so we can get the item object from it, and if the cast is okay, we can call init equipment slot UI. And if it's not, we need to call the same function, but the incoming item gonna be null pointer, and once it's null pointer, it's gonna execute the functionality described further in those functions. So basically, if it's not valid, we're gonna need to clear up the space and reinitialize the UI. Those functions on menu primary get user menu content we already discussed, so we can move next. So the next one is equipment reserve. Here I have a simple border which obviously can contain of one child, and the child is uniform grid panel. This panel contains of 9 elements, and they are referenced to the equipment slot widget that I have here. Each of them set on a particular row and column. You may see changes here on the right. Also make sure that those elements are marked to be variable, otherwise you won't access them inside the graph. So here on the initialized event, we need to extract the equipment component and store it so we can use it further in the init equipment reserve UI function, which we're also gonna call once the widget is constructed. So based on the item type that we get from hovering our mouse over the particular element on the UI, we decide what type of reserve weapon array we're gonna use. We store it as the temporal variable, and then from our grid I get all the children and I want to iterate over them. If the index is valid inside my array that I get from this type of operation, it means that I can extract the item object data and update the slot UI that I have from iterating here. So as you can see, it's gonna update each slot in this reserve menu. But if it's not valid, I'm gonna also call this function, but the incoming item gonna be null pointer, which means that this element should be removed from the child next in the logic, and the UI should be rebuilt. So next one is equipment slot. Nothing fancy here. We have a simple overlay that contains of 2 more widgets. It's an image with a custom shader that I made especially for this feature, and I'm not gonna cover it here in this tutorial. Maybe I'll make it in near future. And the border which stores the rich text. This rich text widget show up a number of items that can be used if this item is stackable. So by default, this widget is hidden to the graph. So on initialized event, we need to store the reference for our equipment component. Don't be afraid too much about performance, because this event is fired only once the game is started. Now let's talk about the init equipment slot UI. So we store the incoming item as an item object reference. It's the global variable. This part you can skip it because it's for the visual representation of a widget. So I just need to get the dynamic material, and I update using this material the background of my icon, the icon texture, and so on. The only interesting part here is that if the item object is valid, it means that I need to update the visual parts, and if it's unique one, I need to set visibility for my number to be hidden. But if it's not, if it's stackable, I need to restore the visibility of the widget to be visible, and then set the proper text, the proper number to show up how many items of a class I have. If an item is not valid, like if we remove it or we use those consumables, we need to restore the default state of a widget. So that's why here I set the attributes for my shader and I restore the visibility of the widget which show up how many items I have. Get last active weapon widget. So here I get all widget of class because I don't have get widget of class in one like the instance, but we don't need to be afraid because equipment we only have one widget here in the container and not in the equipment component. Sorry guys, I'm too tired. I've been trying to record this tutorial for a very long time. So, and based on the item type enumeration from an item object that we have from this function once we init it, we're gonna update the rather custom UI primary, special, or heavy widget. This. Now on mouse button down. So we store the mouse event as the temporal variable. We also check for like if the item is valid, and if it's so, we can continue. Then based on the item type enumeration, we're gonna call two different functions. If it's consumable, we're gonna call mouse use inventory, or if it's equipment, mouse use equipment. We also provide the temporal variable that we created earlier as an input for those functions. Mouse use equipment. Based on an item object, we're gonna refer to the last active weapon, whether it's primary, special, or heavy. We store it to the last active equipment global variable. Based on this variable, we can cast to the weapon base, and if the cast is okay, we can extract the item object to set it as the last active weapon, also global variable. Next, we need to check whether our item object and the last active weapon are the same. If it's true, then we don't need to do anything because we cannot perform action with an item that is equipped. It's by design. But if it's not, it means that we can proceed with the further logic. The left mouse button gonna be used for swapping between our currently equipped item and the one that we are hovering our mouse over. The right one is for dismantling items. So if it's left mouse button, we're gonna play animation that I pre-made. It looks like this. And it simply changed the value in my shader. So then we need to set timer by function name, and it's a custom event called check use equipment. It has a slightly delay before it's gonna be executed. And it's this event. So first of all, we need to clear our timer. Just a good practice to clear after you've done something. Then based on the dismantle boolean type, we rather go to item dismantle, and we call this function from the equipment component reference that we have. We already made this function and we talked about it. And if it's not a dismantle, we're gonna switch our piece of equipment. So first of all, we need to destroy weapon or like other piece of equipment. Then we need to equip item and call item replace in this particular order. Check the references one more time so you won't mess up. For the mouse use inventory, here we check whether it's the left or right mouse button pressed. Left mouse button is for the using item, right mouse button is for dismantling item. We also have the same animation, but another call to the another timer. We set another timer for another function to be called. Also the same delay, 0.35 seconds. And the event is called check use inventory. this one. Also clearing our timer, and based on the dismantle return value, we would rather dismantle item or use item. Also, those functions have been implemented in our equipment component. So finally, the last widget of this feature, inventory. As you can see, it's simple body which contains of a uniform grid panel. By default, it's empty because I'm gonna fill children dynamically. To the graph. As always, on initialized, we store the reference for our equipment component, and we call init inventory UI. On construct, we're gonna call update inventory UI. On init, we're gonna create the grid. So it's 5 by 10. So as you can see, we have for loop twice. We create widget. The reference is equipment slot. This widget. And we add created widgets as a child to our grid. That's it. And the last function here is update inventory UI. So I get all the children from my grid and I iterate through them. Based on condition whether I have the index that I have here valid inside my item list, I'm gonna update the current slot. So I used this index to extract an item from the item list. It's the item object class. And I update the reference that I get from iterating over here. So it's the equipment slot with an item object that I get from this extraction. So if it's valid one, I'm gonna update it and it's gonna have like the icon, the animations. In case if it's stackable, it's gonna have the number of it. And if it's not, it means that we have some items to be dismantled, to be removed. We're gonna reference the null pointer here. And this function is called a lot of places in our code. So guys, the last part of this tutorial is to talk about the foliage and surface interaction while I'm shooting at them. It's gonna be a brief breakdown because I cannot afford right now to make it from scratch, but maybe in the future I'm gonna make a step-by-step tutorial on this topic. Well guys, for those of you who got my updated version of the weapon system, you may find that now projectiles work with the surface and water. So once you start shooting at them, they'll have the appropriate interaction feedback. While I was young and I didn't know how things work, I simply found two different articles, so you can see them on the screen, this one and this one. I'm gonna leave the links to those articles under this video so you can study them, and if you want to replicate it step by step, you can use this as the core to build up the more the complex system that like I did. So I'm just gonna explain the idea behind this each of those features, because they are similar but different, and I'm gonna show how I made interaction in my project or my game. The basic idea which stands behind the surface, foliage and water interaction is by using scene capture component. I have three different blueprint actors that share the same functionality with a slightly different approach. What does scene capture do? It's like the second camera that can store data to the render targets. Then we can sample render target inside our material to be used as the black and white mask, and with the proper scale and the offset, it can work as the track trails to loop between two different materials like ground and snow. You can define what to capture with this setCapture component with the help of simple flags. Here in my example, you may see that I have skeletal and static mesh, landscape and particles. Further, you can, with the help of show only flag, you can mark particular element to be captured, so then the setCapture component performance will be even better. How does this feature work? We need to apply a post process on the setCapture component. So, as you can see under the rendering feature, I have one here. So what it does, it actually checks the difference between the scene depths and the custom depths. Yeah, it means that for this feature to work, all of your meshes should be rendered with the custom render depth path. So the difference is translated to the black and white mask, and our setCapture component should be properly aligned. So it means that it should be perpendicular to our ground and placed underneath the ground. Underneath the ground, in case if you want to capture the like the footprints, but in case of the water interaction, it should be at the top. So it should be in the sky. You also need to be sure that your setCapture component is following your character with the proper offset and the rotation. Otherwise, while your character will be moving, and if it leaves the captured area, your footmark simply won't be drawn. So, you understand me correctly, setCapture component has the effective area of capture. Let's call it like this. It can be defined in the details, so first of all, projection type should be orthographic, and the auto width define the actual size of a capture. It's in units, so it's like 40 meters in this particular case. You can also make a lot of different modifications to the feature. Like you can make your foot tracks not to be constant but temporal. In terms of the winter, this behavior will be like natural. So let me show what I mean. So if we go with the simple approach that we can find in the tutorial, you can see my marks are constant and they are not fading, right? But once I change the behavior with a simple subtraction node, you'll see that once I'm start moving, with some period of time, my footprints fade, and that's the natural behavior. Also, as you can see right now, if I'm moving, it's a simple black and white mask, right? And doesn't have depth, but with the help of simple math, you can actually transfer this, let's call it height field, to a normal map. So now, if we move, you can see it has slight depth. So it also looks more appropriate, more natural. As for the foliage interaction, I used the approach that Charlie, or Prismatica Dev, showed on his YouTube channel nearly 3 years ago. The link to this video I'm also gonna leave under the my video, so we can study it like step by step. Basically, the idea is that, as I showed you, we have the normal map that can you can use it as the vector field to push away or bend vertices of your foliage in appropriate direction in the shader. So it looks like this. This is our render target, and the actual size of it is kind of small. It's 256 by 256. It looks like a normal map, but once I start moving to the foliage bends away and it bends correctly. How actually we can draw something to the render target if we're using the hit scan trace? Actually, on impact for my weapon, I spawn a so-called invisible particle system. This particle system uses mesh renderer, so it actually has the static mesh inside. It's a simple sphere, and for each weapon it has different size. And the magic is that this Negara system is rendered only to the scene capture, not in the main thread. So then, if I pick up a weapon, if I start shooting, it will leave those marks. Same logic with the surface comes to the water interaction, but for the foliage it's a little bit, it's more trickier. So inside the weapon base class, in the function launch projectile, in the flow you can see the new function called simulate foliage interaction. If we open it, you can see that we need to spawn a mockup or like a placeholder actor. We need to provide the proper location and rotation or like the direction. And the base class for this mockup actor is actually like an actor, but it has the projectile movement inside. Here you can see the initial speed of 1800 units and the scale of 0.01. It has a child actor with the reference to the foliage attractor, and it's the actual mesh, which we're also gonna be drawing inside the scene capture. But it has some additional logic, so we have the timeline, which extrapolates over the values, and we store those values to the material parameter collection. We use this material parameter collection in the foliage shader to bend over the time. So that's how it works. So basically it's the sphere that fly through on the high speed and draw to the render target. That's it. What I want to say at the end of this video. With the proper metrics and the proper approach, if you understand how to update, how to maintain your resources, when and what to update, how to delete, how to, like, if you understand the performance cost, the budget, and so, you can actually make the system to be kind of cheap. And I use this one on my laptop with the RTX 350, and it works perfectly fine with the 60 frame on the 1080 resolution, with the high to ultra settings on like kinda complex scene, and it only costs up to 1 and 1.5 millisecond for the whole cycle, for the whole weapons, a lot of simulations and so. For some of you it might be like a drawback, and it depends on the project complexity. Like if you're an indie gamer and you're making the game with a lot of simulations, you want your world to be like fully interactable, you can use it, you can try. With this being said, that's all for this tutorial. I hope you like it and it was useful for you. So in case if you want to support monetarily, you can follow up the link to my Patreon and buy a subscription. Leave your like, leave your feedback, and see you soon, guys.